So I'll point out a couple things. The perception mask, see, is working 180 degrees out of phase with the arm. So now it's taking an image of the conveyor, making sure it's clear, placing the box. While it's placing, it's taking an image of the next row of boxes and detecting what it wants to do. And that's why the robot never stops, right? It never has to stop and wait for the machine learning software to complete. It never has to stop and wait for the path planning algorithm to complete. It's basically able to do perception and manipulation in parallel in a way that it never has to pause.
I don't think
it's designed for higher performance, so it's got more reach, more strength. It can pick up boxes up to 50 pounds and move them at rates up to 800 cases per hour. It also has a couple new really important capabilities. First, there's the smart gripper. So this is a gripper that is rich with sensing and pneumatic control, and we're able to pick up a really wide range of box sizes, but also boxes that are not pristine, boxes that have been beaten up a little bit. This can handle all the kind of real-world cases that you see in the warehouse. There's also an onboard safety system. So if you look down here, there are safety-rated LiDARs on all four sides. And so that enables us to tuck the arm and move in an AMR mode through the facility, meaning that we have a whole redundant safety compute system. And so if we detect any obstacles, we can slow down and stop before anything unsafe happens. We are also meeting the RIA 1508 safety standard with this robot, which is really the first safety standard aimed at mobile manipulation robots. So we're excited for that. The safety system, also we have redundant encoders on most of the motor drives, and that means that if anything happens that's out of control, we're able to safely stop the robot. Cameras and depth sensors. They both work in the dark, basically. They both have illuminators.
So you don't have to be lit.
No. Brings its own lighting. So it's got illuminators for 2D, and it's got time of flight for 3D that basically has active illumination. And so both of these feed into several things. And actually, here, let's take a look over here. Stretch's view of the world, right? So, first, you can see we detect boxes, right? So the machine learning system is able to see all the front faces of those boxes. So those are kind of these front rectangles. And then when we see a new box that we haven't seen before, we'll pick it and then we'll scan it for the third dimension. And that's how we get all three dimensions of the box. Because you can only see the front faces.
So you have right now you don't have any idea of the depth of those boxes, although it's back to the wall. Actually, this isn't the back wall, this is just a volume that it doesn't
as far as you know, right. So what we do is, if we see a box that's front face dimensions are the same as the ones we've seen before, we assume the third dimension is the same. But periodically we'll also scan it and get new data for all three dimensions. So once we pick it up, we can see. In addition to box detection, you can see that we detect the walls of the truck. So here's the LiDAR returns, right, from the floor-based LiDARs. And so we use that for wall detection, so we can localize it in the truck.
Well, you can see the legs of the...
Yeah, right. There's the conveyor legs. We also make sure that we have a clear conveyor. So we always look and make sure that the conveyor is clear before we place the box. So the vision system sees boxes, walls, floors, conveyor, everything it needs to see to basically have situational awareness to do the job collision-free, right? It's one thing to pick up the box, but then, from lots of different kinematic poses, it has to find trajectories to get to the place without hitting anything. And so we put a lot of time in perception and arm path planning to do that.
So you're constantly tucking in and out around to avoid elbowing the wall.
Yeah. We also have a trajectory planner that takes into account all of the kinematic and force constraints in the robot. So we can plan paths and make sure they're kinematically feasible, that we have enough torque and velocity to do them. And so, so we'll talk about autonomous recovery. So, in the real world, boxes fall, right? People drop boxes, robot drop boxes, it's inevitable. But one of the kind of Boston Dynamics capabilities we have here is that we will autonomously recover when we drop a box, and one of those just happened. So if a box does fall, we can detect that we dropped it, and then we can actually reacquire it visually. So we'll back up, take a fresh scan, find where the box landed, and then pick it up and place it. Keep going.
Does the ankle LiDAR see it? It'll see it part of the outline of it.
Yeah. So what it'll do is it'll actually it'll see the outline, which is important because you don't want to roll over it, right? So then it knows it needs to back off a little bit. and it knows it needs to back off, and then use the perception mask to actually get a good detection. So the LiDAR only gives you a little bit of information, but it lets you know that you need to get a better shot. So then the mask gets the full 3D view, and we run box detection.
Define a location for the mask to be in the field of view of the mask.
Yeah, right, exactly.
And then you've also got the live cam view here.
The green outlines are really what the machine learning algorithm
That's an
sees.
actual image.
Yeah, that's an actual image with the green outline on top, and that's what the AI detects.
So what's the user interface going to be for this in terms of the guy that's actually deploying this to go unload a trailer?
So most of it is autonomous. You need a user interface to get the task started, and then once you hit go and walk away, the robot does most of this autonomously. Occasionally it might need your help, so it'll flag you and say I'm stuck, but for the most part, even if it makes a mess, it'll clean up after itself, and the operator never has to get involved. The user interface is a tablet, right? So it's something that is intuitive for anyone to use. You don't need any technical background to operate the robot, and it's mostly drive it into place, get the safeguarding set up around it, and hit go.
So it'll follow. You have to drive it, or will it follow them to the truck back door, open the truck door, and then?
Right now we drive that stage because you need to do it safely. So and it usually only takes a minute. So.